Hello everyone. In this particular video I'm going to talk about what does inverse of a matrix actually mean. Well, I was working on the concept called normal equation in linear regression when I came across this particular formula. If you look at this formula, it says that theta equals to x transpose x inverse multiplied by x transpose y. So if you look over here, we have got the concept of inverse. So for that reason I thought that why don't I make an explicit video where I will be discussing about what does the inverse of a matrix means, and then eventually I will come back to this particular formula of a normal equation in linear regression. In fact, I have already done that particular program. This is the program of normal equation which I will be explaining in my next video. But in this particular video I just want to talk about how we achieve inverse of a matrix and what actually happens behind the scene. So let's consider that we have got the NumPy module, because NumPy will provide us a very wonderful function that is NumPy.linalg I repeat, NumPy.linalg. So we will be giving a call to this particular function present under the module called NumPy. So let's consider I have got one Python list which I pass it to NumPy in order to make it as a NumPy vector. Got it? Okay, great. So here it will print back the vector. So let me do this. Let me comment this entire portion and let me run this code just to see how exactly this looks like. Here it is. So the list which was initially in Python got converted into a matrix of NumPy type. Got it? Okay, great. So now what we are going to do is that we are going to compute the linear algebra. I am going to call the linear algebra inverse function present under the module called NumPy. So when we are giving a call to this, I am passing the NumPy array, and finally I will be getting the matrix. So how exactly this is going to work? Okay, first let me run the code and let me show you what we are getting, and then I will come back. So this is what we are getting. So this matrix is what the inverse of this particular matrix. So how exactly this is going to work? Okay, so if you see over here, when we are talking about inverse, what actually happens is that the diagonal value gets swapped. So 6 comes over here and 4 comes over here, and the offset diagonal gets negated. So that's the reason it's minus 0.7 and this is minus 0.2. So it's been negated. Okay, so that's how the inverse is going to work. So now what I did is that I did a small mathematical implementation of this entire list to show you how exactly are we getting this. So over here, it's actually, in order to do an inverse of a matrix, we have to follow 4 steps. So let me show you these steps one by one, which is actually happening behind the scene when we are giving a call to this particular module called np.linalg.inverse. To reveal those internal steps is what I have done right over here. So I have considered this particular matrix 4 7 2 6. So the step 1 is to find the determinant of this particular matrix. And how do we do that? We have to multiply if you consider this a b c d, we multiply in the form of a into d minus b into c. That's what we have done it. So 4 into 6 minus 7 into, we get the value 10. So that's the determinant of this particular matrix. Okay, great. Now we will do a swap operation. So we are swapping. So swap the diagonal and negate the following negate of the diagonal element. So 4 comes in place of 6 and 6 goes in place of 4, and we are negating the offset diagonal value to minus 7 and minus 2. Great. Okay, we have done that. Okay, now is the third step. What we are doing, we are going to divide each element by the determinant which we have received in the step 1. So A inverse, so the inverse of a matrix equals to 1 by 10 multiplied by the array itself. So the matrix has got 6 minus 7 minus 2 4. That is what getting multiplied, and eventually after we have done the division by each element wise division, after we have completed that, the final matrix which we are getting is right in front of us is 0.6 minus 0.7 minus 0.2 and then 0.4. So this is what actually we are getting as an inverse of the following matrix. So whenever we do inverse, this is what actually happens behind the scene. These three steps are actually followed. Now I have gone one step farther just to check that whether my inverse was actually obtained correctly or not. So it's a one extra step I'm doing as a form of verification. So what I'm saying is that we are going to verify that the inverse of the matrix is actually the correct inverse of the original matrix or not. So how do we do that? Well, if I multiply the original matrix with the inverse form, we should get the identity matrix. So what the identity matrix looks like? It looks like somewhat like this: 1 0 0 1. So after the multiplication of these two matrices, if the resultant matrix is the following, then we would say that yes, the inverse matrix has been successfully obtained. So how do we achieve this? So for that reason, Python in version 3.5 has introduced a very wonderful operator that is called matrix multiplication operator in the form of @. Remember, this particular operator will be even used when we are going for normal equation of linear regression. There also we will be using this. So this operator is really very handy, and it performs the matrix multiplication within like at a lightning speed. So we are going to multiply the original matrix multiplied by the inverse matrix which we have obtained. That would get that's what we are going to get, and then we are going to print the resultant matrix, which is the identity matrix, and we will see the identity matrix would look somewhat like this. So let me run the output once again to show you what we are obtaining. Yes, and here it comes. Look over here, what the resultant matrix we have obtained. Identity matrix looks like this. This is positive value, so it's going to be 1. This is a negative value, see, minus 16, so it's going to be 0. This is also going to be negative value, so it will be also 0, and this is going to be the positive value, this is going to be 1. So 1 0 0 1. So after we have done this multiplication with the actual matrix with that of the inverse of the matrix, we get the following identity matrix. Hence the inverse result which we got right over here, this result is actually in the correct format. So what we did, let me show you over here as well. So A into A is my original matrix which I've written over here into inverse. This is my inverse matrix, that's what we have written. So we are now going for matrix multiplication, and this is done by the special operator called @. And after we have done this two step, finally we are getting the resultant output in the form of identity matrix. Hence we come to the conclusion that the resultant inverse of the matrix was actually correctly obtained, and that what got verified by executing this particular step. Got it? So in this particular video, I just wanted to show you that how exactly the inverse of a matrix is obtained, because this is really very important in order to understand a good number of equations upcoming which I will be working on, and like what we have done right over here in context to normal equation, and that would result in the form of linear regression. Well, this particular video, this particular program will be my next video's content, but before I get into this, that's the reason I thought to come up with this one, and I believe this entire step-by-step formulation will really be helpful for you to understand how exactly we obtain an inverse of a matrix. Okay, so that's all from this video presentation. Thank you very much.